So let's talk about something fascinating. We're going to explore this incredible link between two worlds you probably never thought to connect: how a little kid learns to count and the actual future of artificial intelligence. It turns out the secret to building smarter AI might have been hiding in child psychology textbooks for decades.
To get started, I want you to think about something for a second. And I mean, really think back. How did you actually learn that 2 plus 3 equals 5? Did a teacher just write it on a board? And bam, it was instantly in your brain forever?
Yeah, I'm guessing it wasn't that simple, right? For pretty much all of us, learning something, even a basic math fact, isn't this neat, tidy process. It's not like downloading a file.
The truth is, real learning, it's messy. It's much less like climbing a ladder one step at a time, and a lot more like a bunch of overlapping waves crashing on a shore. And that idea of waves is what we're going to dive into right now. And that brings us to the core of this whole thing, a really powerful theory from a psychologist named Robert Siegler, which pretty much reshaped how we understand the way our brains develop. So here's the big idea behind Siegler's overlapping waves theory. When we're trying to learn something, we don't just pick one method and stick with it. Nope. We have a whole toolkit of different strategies all bouncing around in our heads at the same time. Things like guessing, counting on our fingers, trying to remember, they're all competing for our attention. Okay, let's make this real. Picture a kid trying to figure out 8 plus 3. On Monday, they might just take a wild guess. 10. On Tuesday, they might pull out their fingers and carefully count up. 9, 10, 11. Then, after enough practice, on Friday, they just know it. Boom, it's 11. All those strategies, those waves, are sloshing around, one becoming more dominant until it's the one they rely on. And this isn't just some nice theory, it's backed up by a ton of research. Siegler found that really little kids have this kind of warped number line in their heads. Small numbers are clear, but bigger numbers kind of get all mushed together. But as they learn, using all those different strategies, that mental map slowly flattens out and becomes the straight, accurate number line that we all use as adults. Okay, so that's the psychology. Now here's where things get really wild. What happens if you take this classic, decades-old theory and you use it to teach a brand new artificial intelligence? What if you tried to build a digital toddler? See, most of the big AI models you hear about today learn through sheer brute force. They basically read the entire internet and get really, really good at guessing the next word. But some researchers tried something totally different. They built what they called a small math model, and instead of force-feeding it the internet, they taught it to count just like a kid does, mistakes and all. And the researchers weren't being subtle about this at all. They said it right in their paper. They were literally taking that psychological theory we just talked about and building it into an AI. In other words, they were using what we know about how human brains learn to create a new kind of artificial brain. They were building the overlapping waves theory out of code. So the big question is, did it work? Can you actually see an AI learn in waves? Well, let's look at the data, because this is where it gets really cool. This is the aha moment happening right inside the machine. Okay, wow. This is the money shot right here. Look at these two graphs together. The one on the left shows the AI's use of a finger counting strategy. See that wave? It goes up, hits a peak, and then starts to fade. Now, follow that peak over to the graph on the right, which shows the AI's accuracy. You can see its accuracy really starts to skyrocket right as that finger counting wave is at its strongest. It's amazing. The AI is using the slow but reliable strategy as a crutch to build confidence, which then lets it master the faster method of just knowing the answer. This is exactly what kids do, right? When the AI isn't sure, it learns it can fall back on a method that's slower but always works. The researchers even compared this to how we can teach giant language models to use a calculator when they don't trust their own math. It's about learning how to find the right answer, not just memorizing it. And just look at the result. It's incredible. On the far left, that's the AI early on. Its answers are all over the map. It's just making wild guesses. But as you move to the right, as it keeps training, its answers get laser-focused, clustering right around the correct solution. It's not just getting the right answer, it's becoming sure of the right answer. It's actually developed a kind of number sense. Okay, so this is a super cool experiment, no doubt. But so what? Why should we care about an AI that learns math like a toddler? Why does any of this matter? Well, the takeaways here are actually huge. For the world of AI, this shows a potential new path forward, a way to build models that have a genuine, more human-like understanding of things. For psychology, it's this amazing new way to test theories about our own minds. And for all of us, it gives us real insight into how we can teach our kids better. It's a powerful reminder that learning is supposed to be messy, that having a few different strategies is a good thing, and that making mistakes isn't failure. It's just one of the waves you have to ride to get to the answer.
You know, it's funny. In trying to build a machine that learns more like a human, we're not just creating a smarter tool. We're building a new kind of mirror, a way to see our own intelligence in a new light. And it leaves you wondering, if an AI can learn something as human as making a mistake and trying again, what else can it teach us about ourselves?